Hello, my name is Hajime Sugiyama and I'm an Industrial IoT Evangelist from Mitsubishi Electric. As part of my latest Industry IoT Trends for Everybody series, today I'd like to talk about Industry IoT, mistakes made, lessons learned, and sustainable Kaizen activities. We're talking about the smart manufacturing Kaizen level. I think there are a lot of people that have gotten management orders to install things like AI, data analytics, sensors, 5G, remote maintenance in their factories. It's not so easy. So in today's presentation, I want to show some examples of mistakes made and how we can learn from them. This is a survey result, and it's a reality check because it says that 85% of businesses say they understand the potential of Industry 4.0. So this means that everybody knows that Industry 4.0 is important and they do want to install it in their factories. On the other hand, only 10 and 50% have detailed strategy in place for Industry 4.0, meaning that they know it's important, but there's a very few amount of people that are actually doing it. Here's another reality check from the survey. For predictive maintenance, 87% of companies say that real-time data is essential to do these kind of predictive maintenance applications. But again, in reality, even in the most sophisticated manufacturing facilities like Germany, Switzerland, and Austria, only 9% of the companies can measure their operations based on real-time data. So most of their companies are not collecting data in real time. What I'm trying to say is there's a gap in everybody's wishes and where the factory floor level is. And so this is going to be a big hurdle in installing these Industry 4.0 industrial IoT applications. We've been doing IoT for the factory for 17 years in Mitsubishi Electric, and I want to share some typical struggles of our customers when they try to put Industry 4.0 in their factories. Here's an example that happens a lot. New Industry 4.0 production line design. So there's a new product coming out and they want to do an investment. So they said, oh, this is a great idea to test Industry 4.0. So let's do full automation. We want to install AI and machine learning. We want to do the digital twin. We want to connect cloud, use wireless 5G technologies, and make a fully autonomous factory with no line workers. Okay, let's start the project. But a lot of time, the proposal is rejected. The first is the high cost involved in these kind of applications. Normally, a production line manager is used to working with machines, robots, PLCs, sensors. But if you want to do this kind of Industry 4.0 type application, you're going to have to need different aspects. You're going to need to calculate the server costs, the cloud costs, the AI costs, the drone cost, and all the communication costs related. And usually we don't have the experience to we are not used to working with those kind of vendors. So it takes a lot of time to get the quotes together. And when you get the quotes, usually it's an unbelievable high amount of cost. Okay, you look at the quote, but this is the cost of Industry 4.0 and IoT. As long as I get the return of an investment, then we can justify the costs. So then they start calculating the return on investment. But it's really hard to calculate return of investment in Industry 4.0. For instance, predictive maintenance. Can you really predict and estimate how much cost you're going to save? How much time you have saved the line from stopping? How much efficient is AI going to help you? Even before you get a result. So it's really difficult to calculate the ROI as well. And what happens, and what is the true story, is that nobody knows about Industry 4.0 industrial IoT because nobody's made the factory by themselves. At the end, a lot of time, the project is rejected because they cannot justify the ROI. They sit down with management, they look at the high costs involved and say, okay, maybe it's too risky, it's too expensive. Let's do it the second time around. And the project doesn't go through. And this happens a lot. Other company says, okay, we don't want to do a full-scale production line. Let's maybe go into detail for this machine because it stops the production line a lot with quality issues. This is an example of a customer that has a plastic injection molding machine, and a lot of times the quality goes bad in the product. So they said, okay, we have this quality issue, but if we kind of look at the parameters of the machine, we monitor the currents of the electrical currents, vibration, maybe we can find out the problems of the product quality before it goes wrong. So they said, okay, let's use data, let's do a data analytics project for predictive maintenance for this machine. We want to improve quality, and in order to do that, we're going to use real-time data collection, real-time data analytics, edge computing, and AI to do this. So they did the project for 6 months, accumulated data, do the data analytics, make the data model, put it back into the machine, and start gathering machine to see if they can predict failure. They went through the first run, but they found out that only 50% of the time they could predict the failure. Meaning 50% of the time it would tell them that the machine is going bad, so probably you're going to get a bad quality part. Problem is, the other 50% of the time, the edge computer and AI could not detect that was happening. This is an issue, 50%. In manufacturing, we're always going for 100%, so 50% is not good enough. The other issue is, even if they could find that something was going too wrong in the machine, they detected the data was going in a bad direction, they could not define the root cause of the failure. So they could not say, okay, this motor is going wrong or this gear is going wrong. It could not define the root cause. So what they had to do is they had to do maintenance on the entire machine because they couldn't find the problem, and then they would do it. So they had these two issues and said, okay, this is not fit enough for manufacturing. What they did is they did it again. So let's try other data again, collect other data again, and then see if we can find the root cause and raise this failure prediction rate. Okay, it moved to 50% to 70%, but still 30% of the time they could not predict that it was going to fail. And they still could not define the root cause of failure. So another 3 months waited, total 9 months wasted. So they said, okay, this is not good enough for prediction. It's probably better off if we do maintenance on this machine periodically. And on the other hand, they said that, okay, usually when you do IoT projects, you're using your ACE engineers on the factory floor. So they had the ACE engineers on this project tied up for 9 months. He said, okay, this is not a good use of resources. So they said, okay, let's fold up this project and use these key engineers on something where we can get a better ROI. It's no sense in doing this project again and wasting another 3 months and 6 months collecting data. So we moved on, and the IoT project stopped. These are just two examples of failures, but there's many, many more failures in IoT that we've heard from our customers. For instance, you monitor the energy in your factory, but you don't know how to save the energy. You're just monitoring and looking at these neat screens. You're trying to install sensors into old equipment in order to gather data, but the installation cost is incredibly high because you have to reroute the wiring, and sometimes you even end up engineering a new machine because it takes too much time putting these sensors on an old machine. Data analytics are very complicated. A lot of time the factory staff does not know how to handle it and use the software problem, and then you use consultants to try to help you. But of course, the consultancy cost for data scientists is not cheap. So there's all these failures. So, it's not easy, industrial IoT. One advice and one lesson we learned from ourselves is, of course, you need to dream big when you do Industry IoT or Industry 4.0. There's a whole picture, including the supply chain, how you want to integrate data, put it into the cloud. But when you do these kind of IoT investments, you want to start small, where you can calculate. Don't start with the whole entire factory line. Start with a single cell, for instance. Okay, go to the packaging machine, see if you can replace it with a robot, see if you can calculate the data, see if you can use the data to improve your processes, and calculate if you're really getting return on investment on this application. I mean, at the end, you can spend tons of money on Industry 4.0 and IoT, but if you don't get the return on investment, it's not worth it. Right? We're in manufacturing. The most driver is cost. If you're successful at this, then you can move down the line. Okay, try other machines, see if you get ROI, and if each machine you see you're getting your ROI, then you can look at the production line as a whole. So it's a step-by-step process, but always calculate the ROI. One more important thing we think is to set KPIs and agree with this with management. Where are you going to put IoT, what level you're going to put IoT, and what direction you're going IoT. Because the expectations from the factory management, which usually don't have a lot of knowledge about IoT, is very, very different from the expectations and the results that the production line can produce. I mean, mostly management thinks with even a small investment, you can get data analytics, you can get AI, and you can get Kaizen, which is not really the story. So first, when you start a project, you always want to be in agreement with management of what you're going to achieve out of this project. I have a map over here, and if you think about it, when you ride a boat, you always want to define if you're going from Japan, if you're going to Europe, or if you're going to Hawaii, or if you're going to Africa. Why I'm saying that is because the resources from people and the food you put on the boat is totally, and the gasoline you put on the boat is totally different. And you need to define these resources before you start the project, because it's going to cost money. So that's why we always say, okay, first set some KPIs, what you're going to achieve, and then start the project. This is why in Mitsubishi Electric, we use this kind of KPI agreement process called Smart Manufacturing Kaizen level. When we start a project, we always try to decide with management where we're going, what level we want to achieve with IoT, and then define the KPIs related to that. After we install the project, we talk again and say, okay, this was achieved, and we got our ROI back, so can I move on to the next level? This is a kind of tool that we use to get everybody in sync. In the first survey, I talked about there needs to be steps of going into manufacturing. I mean, most of the companies, they want to do Kaizen, they want to use AI, and they want to use optimization, but without data, you can't do anything. So that's why, in terms of maturity level in a factory, we always start with the level, first you have to collect data. Only after you being able to collect data, then you can visualize it. After you visualize it, put it in charts, then you can analyze it. And after you analyze it and you're able to kind of say, okay, this is something going wrong, so let's send an alert, then you go to the phase which is called optimization. For instance, okay, we've analyzed that the temperature is too high, then let's open this valve so we can put air and water to lower the temperature. It's always a step-to-step procedure with IoT. In order to get to this analyze phase, this optimize phase, you first have to collect. So the first steps of investment are always first collecting the data and visualizing data. And this is a step-by-step process. It's also corresponds to the area of you have to go step by step. I mean, you're not going to be able to do IoT Industry 4.0 the whole factory. It's always a sum of the individual parts. So first, for IoT, you would work on a manufacturing cell level or a machine level. After you're able to achieve the IoT on this cell, then you can move to other machines. And if you're able to put IoT on all these machines, then you can do the analyze and optimization of IoT on a line level. Then you combine lines together, manage IoT as a whole, entire factory, and after that, you can start working with separate companies, external companies, in order to optimize your supply chain. But as I said, it always starts small, and then you have to expand. So it's a step-by-step process to do this. And that's what we do. You need to take a step-to-step process in order to achieve industrial IoT throughout your factory. So if you're talking about assembly line, you first work at a cell level. Okay, you say, can I collect data in this motor assembly cell? Okay, you use RFID, use sensors, use barcodes. Now I'm ready to visualize what happens in the manufacturing cell. After you visualize, then okay, now I'm going to do analytics, and finally you're going to go to the optimization cell phase where you optimize the data automatically. If you're finished with that cell, you work on the other cells, and then you can move to the workshop level, factory line level, and eventually you'll go to the factory level. But you have to go step by step. You can't skip all the way to the factory. It always starts with an individual cell, and it always starts with collecting data. Interesting enough, sometimes it goes a different direction. For instance, in this case, if we talk about energy saving, the approach to energy saving is you don't want to work on small energy savings where it's not crucial. First, your goal is to find out, okay, in my entire factory, where am I using the most energy? Because the factories that use the most energy have the most room to save energy. So first you would do monitoring of your entire factory. Okay, which factory am I using the most energy? And you're saying, okay, maybe my motor factory is using the most energy. Okay. Then let's say, okay, let's go into the motor factory and look at the production lines and machinery. Okay, which machine is using the most energy? Okay, maybe it's an oven. Okay. Then I know, okay, this should be the focus of my saving energy. So let's go to this oven and see how we can save energy. So you collect the data, various aspects, you visualize it, and then you analyze it, and then you can find the root cause of your energy usage and do improvements. So sometimes it goes different directions in this MSKL chart. Okay, enough about theory, and next I would use some actual examples in smart manufacturing Kaizen level in Mitsubishi Electric, because we started to use this as a good KPI inside our own factories. Every time when we do manual annual planning, we make this kind of mapping and planning chart. We look at all our workshops and all our production lines, factories, to see, okay, where is the level of IoT in my factory? Am I at 2B? Am I at 1B? And this is the goal that I want to achieve next year. And in order to do that, I want to do these kind of IoT investments. And it's going to cost this amount of money, but it's going to save this amount of money in production costs. We lay these out and we make these kind of application sheets to submit to management. As I said, to agree, everybody to agree on what we're going to achieve this year in manufacturing. Then we make these kind of detailed proposal sheets of how we're going to implement IoT for each production line. And in this case, I want to show you an example of our motor assembly lines. We had some issues with the motor assembly line, and it's good to always start with pain points, because the pain points are the places where you definitely have room for improvements. In this case, we had a manual motor assembly line, but the issue was it took a lot of training in order to have a new worker learn to assemble a motor. First, he would look at these kind of books, he would study by himself, and then after that, he would practice by himself. He would actually assemble the motor by himself. In the latest stage, we would practice with a supervisor. So a supervisor would stand by him or her and look if he was doing the process and assembly correctly, but it took a lot of time. The other issue we had was there was a lot of human errors in the assembly process, because there were many, many different types of screws involved. So there was potential of mistakes of using the wrong screw for the wrong hole. And these kinds of human errors happened with new employees, but also they happened in what we call since-a-while workers that, because we rotate our workers, they haven't made this motor in 2 weeks or 3 weeks, so they forget how to do it correctly, and they make human errors too. The other thing was efficiency, Alice. We had problems with this manual motor cell because, we only were monitoring their efficiency by stopwatches. So every 2 weeks or so, we would take a stopwatch and see and trying to kind of record how efficient they were in manufacturing. So it was difficult to analyze, the efficiency of our workers. So these were the pain points, and we said, okay, can we use IoT to solve these problems? So what we did is we said, okay, let's use IoT to solve our problems. And we tried to we proposed the introduction of a smart work navigator system. It looks like this. So what we have is a screen that we're using, and it automatically tells the worker step by step where to put the screw, which screw to use, and the points that he has to be careful when assembling a motor. The good thing about this is because he doesn't have to look at the manual, learn by himself. It's easier to educate them because they just have to look and follow the instructions on the screen. So he said, okay, if we do this, of course we have to double check if the employee is doing it right. We should be able to reduce the time of education for an employee from 10 days to 5 days. So this is double because it's not only the assembly worker, it's a supervisor. We reduce the time for him as well. And then, we calculate the number of times of education we do to new workers, 12 months, and the workly fee rate for the workers. Then we calculated the investment cost for this line. We'll put it in 2 lines, and then we get the ROI. We said, okay, we should be able to get back the costs in about 2.8 years. And we said, of course, it's 2.8 years, but we get other beneficial effects. First, we will be able to reduce quality loss because they will be sure to use the right screws in the right places because the instructions are very easy. And also, by installing this kind of system, we will be able to automatically measure the time that it needs to do each process because every time they press a button, it moves and they can automatically recording what time it took. We got the approval for this, so we installed it on our factory line. And we were able to reduce the education time. So this is theory, we monitored it. We were able to eliminate assembly human errors. We were able to automatically measure and check data when they were tightening screws. And we were able to measure the assembly time by worker by process. So at the end of the 1-year review, we told management, see, we achieved ROI and it was a good project. Okay, let's move on to the next step. Because this was good, but we found out a lot of other issues when installing IoT. These were our next challenge and pain points. First of time, the smart worker navigator is not automatic, so you actually need to take the photo, then modify it, modify the photo, check it with the drawing, and program this smart work navigator system. So this takes a lot of time itself. The other problem we have is we actually were doing a lot of time kitting, the screws, and it took a lot of time. So the operator was preparing the correct screws required for each product and then handing over to the worker, but this was time consuming. The other thing was we were able to automatically collect the data, but we're not using it. So we had the data and it was just lying around because it took a lot of work to kind of reconfigure the data in a format that we needed to understand how to use it for Kaizen activities. So we made the next investment plan and we submitted to management. So, okay, in order to simplify the preparation of the digital manuals that we put in our smart navigator system, okay, let's leverage the 3D data from the design phase. We know our engineers, when they were creating the motor product, they had 3D design. So is there a way to put a system and automatically take out the data and put it into this assembly system? Okay, maybe there's a good way to do that. The other one is, okay, rather than kitting the screws and giving it to the worker, if we can automatically tell the worker and show the worker which screws to use at the assembly table, we will be able to reduce the time of the kitting. So let's install a Pokoyoke system. The other thing is, okay, let's introduce a data utilization system so it can really pinpoint, the bottlenecks of who's taking a lot of time in assembly. So again, we have to prove ROI to our management. So we said, okay, improvement 1, we'll be able to save 120 hours. Improvement 2, 75 hours. And with improvement 3, we should be able to reduce the lead time by around 18 seconds. We calculated the investment cost. It's about 5 years, which is very, very long from our standards. But we decided to go ahead with this investment because we were sure these systems could be used in other production lines. So, of course, it's 5.0 here, but for other production lines, when we install the other production lines, we will be able to get faster return investment periods. So these are the results that we showed. Okay, it was simple by using the 3D simulation data that we got from the engineering section. It was easier to make these kind of smart navigation system manuals. We were able to eliminate the assembly errors by using a Pokoyoke system. As you see over here, when the assembly process comes up, it automatically has a light, and they pick up the screw where the light lights up. So no mistakes, and also most important, no kitting necessary. And we made a system so we can immediately identify the bottlenecks and processes by utilizing the data we collected. We were able to show that it was correct. We got the return on investment. Our management was happy. And the process goes on. We had to go to the next steps. Because every IoT project is not, a dream story. It always has its issues. We found out other issues because in the middle of the night, we had a network issue with our central server going down, and all our networks went down. The issue with this is because all our navigation screens were connected to a central server, and every time they changed the product, we had to retrieve the data from the server. With the network down, all the assembly cells had to stop. It was the middle of the night, so no network expert was on hand. So we had nothing to do. There's nothing we could do except for wait till the network engineer could come to the factory and get it running. What we thought is, okay, we have to fix this because it was a huge loss. We were stopping the production line for 6 hours. So let's use edge computing. We need to have the capabilities to work even if the network goes down. So maybe we should save these kind of screen data in edge computers near the factory. Also, we said, okay, but there's going to be other network issues in the future. And sometimes maybe something will happen with the edge computer. So we have to have probably a backup plan where we are able to assemble things offline, not even using the smart navigation system. So emergency plans. The other issue is, okay, this kind of smart navigation system was good for new people and once in a time workers for assembly. But we have very, very good skilled workers working in the assembly line that don't make any mistakes. It's by data proven that they're very fast and efficient and their quality is 100%. That's why we also said, okay, by doing this step-by-step process with our skilled workers is actually slowing them down. So what we're doing is we're introducing an expert mode for these kind of skilled workers where we're making sure that we're checking the quality 100%, but they can move at a different level and speed. And finally, we're considering more improvements using data visualization and AI, and we want to kind of be able to instruct the workers in the factory, okay, do this next, do this next, this line is slowing down, so you probably need an extra worker, so kind of a device function. And we want to achieve this and go to the next level in our production lines. Okay, so this is kind of, I think it was a good example of how you move step by step. One important thing and interesting you can use with smart manufacturing Kaizen level is if you understand where you're going, then you can know what kind of technology you need for your employees and plan the training. I mean, if you want to do optimization in analytics, you need a knowledge of AI and edge computing. Okay. If you don't have the engineers or production facility staff that know this, you're not going to be able to do this. So first, when you lay out SMKL, you have to think, okay, all our engineers only know PLCs, programming, networks. But in order to get to the analytics of optimization, I have to train them for AI and edge computing. And then you say, okay, we have to wait 6 months till we be able to get these engineers to this level, and then we can start the IoT project. The same thing when you look at a factory level and supply chain level. Lots of people are thinking about utilizing the cloud, but in order to use the cloud, you have to have the engineers that know about the cloud. So you say, okay, I want to move to this level, so I'd probably be recruiting an IT engineer, extra IT engineer for my factory. The other thing you have to think of, if you're handling the cloud, security knowledge is a must, because you're connecting outside of the company, and you have to make sure that your cybersecurity is good enough that you don't have hackers hacking into your system and stopping the production line. So if you know what level you're going, and you plan what level you're going, then you'll be able to plan what kind of education you need for your engineers. I think it's going to be extremely important for the knowledge of the cloud and security, because in the past, we were just talking about connecting things inside our factory, but more and more as we move to a cloud-based engineers, and everything's going to be connected to the cloud. And that's why you're going to have, even if you're looking at a cell level, these engineers are going to have the knowledge about IT connectivity, and also cloud, and also security. Okay, our Kaizen journey continues. I'm sure your Kaizen journey is continuing. But also as Mitsubishi Electric, we're trying to kind of use these kind of systems and also provide it to help you, because we've already went through these kind of journeys, and we have a lot of easy tools for use when you try to do the same approach in your factories at a cell level, and sometimes at a more factory line, workshop level, SCM level type. Okay, this is the end of my presentation, but some takeaways. KPIs, return on investment, you have to agree on this, and you have to be able to have to prove to it, and it's stepping stones. So you can't go to the entire factory AI at one single shot. First, work at a cell level and see if you can achieve the ROI necessary, then you can go to the next steps. And it's not rocket science. It's a basic map your IoT activities, plan your IoT activities, do your IoT activities, check if it's working. If it's not working, then modify. So this is the roots of manufacturing in Kaizen. This SMKL was originally developed by Mitsubishi Electric, but we find that a lot of companies are interested and they want to learn of how we're doing implementing IoT. So that's why we're working with other companies in an industry automation forum, and we're trying to standardize the KPIs and these kind of KPIs that we use in smart manufacturing Kaizen level, because they're common for all the companies in manufacturing. Okay, what KPI should I monitor? OEE, energy saving, lead time, takt times, all this kind of quality issues, all this kind of stuff. There's some kind of basic parameters that everybody use, and we're putting these into kind of white paper and as a standard. And in the future, we'd like to propose this to ISO and IAC so we can share with everybody to make a better manufacturing community. Okay, today I was just covering some of the topics that we can share with you, but I have a lot more videos in YouTube addressing things like edge computing I've talked about, data analytics I've talked about, energy saving I've talked about. So if you have the time, take a look. Okay, this is the end of my presentation. Thanks for listening, and bye-bye.